Good afternoon to everyone. How are you all? I welcome you all in this session of Physics Class 11th Enable Plus program. And the topic that we are currently studying is motion in straight line. Yeah. Welcome, guys. How are you all? Good afternoon to everyone once again. So have a look. We have in the panel. It's Bindu, Dhruvi, Prajapati, JNV Bhavnagar, JNV Gadak, Junagadh, Ramnagar, Shimoga, Soreng Sikkim, Yachuli, Kolhapur, Srinidhi, Suprit, Tarun, Vikas, Wangtoy, Sri Lakshmi, Vijayanagaram, S. Shivanand Patil, and Vara Lakshmi. So I welcome you all in this session of motion in straight line. Okay, so first of all, make sure that screen is perfectly visible to you and I'm perfectly audible. And for that, I'm just launching a poll. Just answer in that poll. Do not need to write this thing in the chat box. Okay? Answer rapidly in the chat box. As soon as you answered, we will start the session. Okay. Okay. Participation is only 42%. Make it at least 60 plus. Only 9 student has participated in the poll. 10. Okay, very good. 11. Make it 20. Make it 20 first of all. Make it 20. Rapidly. We have a lot to discuss today, yaar. Do it. Okay, 11 student has participated. What about others? You can also use the chat box to answer. अरे जब मैं बोलूंगा तभी तो आएगी ना आवाज तरुण. नॉट स्पीकिंग देन. ओके ओके ओके. ठीक है, तो टॉपिक फॉर टुडेज क्लास इज ओके. आई थिंक आई ऑडिबल एंड विजिबल टू ऑल. नो प्रॉब्लम. ओके ठीक है. चलिए तो पोल को एंड करते हैं. ओके. So topic for today's class is motion under gravity and graphs for motion. Graphs of motion. In the previous lecture, what we have did, we have derived the general equations and the with the help of the general equation of motion, we have derived the UAM, which is uniformly accelerated motion. Okay. So the number of equation that we have in UAM is 3, and we have derived all the threes. Good afternoon, Jane Vikar. Now in this lecture, we are going to see motion under gravity and graphs of motion. Yeah. चलिए first of all start करते हैं. In the previous session, if anyone has any kind of doubt, you can ask right now. किसी को कोई डाउट है इन द प्रीवियस सेशन? मैंने आपको एक होमवर्क भी दिया था ना. हाउ मेनी ऑफ यू डिड? दिस इज योर होमवर्क. आई हैव गिवन यू. I know that I have given this is your homework. How many of you have did it? No one. Say yes and no. No problem. Say yes and no. How many of you did it? Chalo, we will start to doing this question. first of all. So in this question, u is given as 6 meter per second. U is the initial velocity. A is the acceleration, which is minus 2 meter per second square is given. Time is 4 second and 2 second. Pe we have to find out distance and distance. So to find out distance, first of all, displacement we will find out. Displacement for, let's say 4 seconds. So it is S4 I am writing. This acceleration is uniform. There is no variable present in the acceleration, so we can apply the equation. S4 is equals to ut plus 1 by at square. Okay. What is the value of u? 6. Time is what? 4 second plus 1 by 2 times minus of 2 into 4 square. This 2 and 2 will cancel out. It will become 24 minus 16, which is 8 meter. Okay. Now for S2, for 2 second का displacement, what we will do? Ut plus 1 by at square. So u 6 t is what? 2 second plus 1 by 2 times 2 into 2 का square minus. This will cancel out. It will become 12 minus 4. 6 to the 12. 12 minus 4 is 8. देखो 4 सेकंड में भी कितना आ रहा है? 8 मीटर. 2 सेकंड में भी कितना आ रहा है? 8 मीटर. Which something is happening. है ना? Look. First of all, in these types of question, when you find some disturbance in the displacement, you need to find out where the velocity is being zero, because acceleration in the opposite direction of the velocity. So the motion of the object will be like this. It will definitely going to take a turn. So you have to find out the time where velocity will become zero. So we apply this equation, v is equals to u plus at here. V will become 0. U is 6 minus 2 into t. So the time for becoming the velocity 0 is 3 seconds. So at 3 seconds, the particle will take turn. Okay. Now, what is the distance in 4 seconds? In 2 seconds, first of all. Distance in 2 seconds. So simply you can apply this equation because the particle is taking turn at the end of 3 seconds. Okay. So up to 3 seconds, you can apply the distance and displacement same equation. There is no problem. So ut plus 1 by 2 at square, and as we have already calculated at 2 seconds, it is 8 meter. So distance is also 8 meter for 2 seconds. Now, displacement, sorry, distance for 6 सेकेंड, सॉरी 4 सेकेंड. तो इसके लिए क्या करना है अपने आप को? मैंने आपको बताया था कि फर्स्ट ऑफ ऑल कैलकुलेट द डिस्टेंस अप टू द पॉइंट वेयर द वेलोसिटी इज बिकमिंग जीरो. ठीक है. तो वेलोसिटी कहाँ पे जीरो हो रही है? 3 सेकेंड पे. तो 3 सेकेंड की डिस्टेंस फाइंड आउट करो. 6 इंटू 3 माइनस 1 बाई 2 इंटू 2. 3 का स्क्वायर इज 9. It is 18 minus 9, which is 9 meter. Okay, clear? Now, when the particle has take turn, अब पार्टिकल ने टर्न ले लिया है, तो यानी कि टर्न पर वेलोसिटी कितनी होगी? 0. तभी तो टर्न लिया होगा ना. नाउ कैलकुलेट द डिस्टेंस फॉर द रिमेनिंग टाइम. अब हमने 3 सेकंड का तो कैलकुलेट कर लिया. कितने का चाहिए? 4 सेकंड का. तो कितने सेकंड के लिए कैलकुलेट करेंगे? 1 सेकंड के. ut प्लस 1 बाई 2 at स्क्वायर. अब देखो u क्या लेंगे यहाँ पे? बिकॉज वी आर स्टार्टिंग द मोशन फ्रॉम दिस पॉइंट, फ्रॉम द टर्निंग पॉइंट. तो टर्निंग पॉइंट पे इनिशियल वेलोसिटी क्या हो जाएगी, जीरो हो जाएगी। ये फाइनल वेलोसिटी ही इनिशियल वेलोसिटी बन जाएगी वहां। सो बिकॉज नाउ वी आर ऑब्जर्विंग फ्रॉम हियर, दिस यूटी विल बिकम जीरो। 1/2 -2 t square is what, 1. This and this will also cancel out. It is coming out to be minus. ठीक है, -1 means this is the displacement, but if you take the mode of it, it will coming out as a distance, 1 meter. Now add it. S4 is equals to distance S3 plus S1. S3 is what, 9 meter, and S4 is what, 1 meter plus 1. So it is coming out to be 10 meter. And you can justify this equation also. देखो 4 सेकंड पे डिस्प्लेसमेंट इज 8 मीटर, विच मीन्स ये कितना रन किया होगा, जस्ट अ सेकंड, इरेजर इज नॉट वर्किंग। चलो यहाँ पे बता, देखो 4 सेकंड पे ऐसे, तो यहाँ तक एट द एंड ऑफ 3 सेकंड कितनी डिस्टेंस ट्रेवल की है, 9 मीटर। 3 सेकंड में 3 सेकंड में कितनी डिस्टेंस ट्रेवल की है, 9 मीटर। और उसके बाद ऑपोजिट डायरेक्शन में कितनी डिस्टेंस ट्रेवल किया, 1 मीटर। तो डिस्प्लेसमेंट कितना हो जाएगा, इनिशियल पॉइंट ये था, फाइनल पॉइंट ये टोटल 9 है, और ये टोटल कितना होगा, अगर ये 1 है तो ये होगा 8। तो ये जस्टिफाई कर रहा है। ठीक है, क्लियर है एवरीवन? एनी काइंड ऑफ डाउट इन दिस क्वेश्चन? Say yes or no, or you can unmute yourself and then say. Any kind of doubt in this question? ठीक है, चलो नेक्स्ट। Okay, very good. Now we will start the today's topic, which is okay. Okay, Varalakshmi, very good. What about you, JNV, Sorang, Sikkim, Srinidhi, Tarun, Sri Lakshmi? What about you guys? चलो मोशन अंडर ग्रेविटी के बारे में बात करते हैं। Motion under gravity is simple. When the value of acceleration replaces itself to the value of gravitational acceleration, तो इसकी certain assumption है। First is air resistance is not considered. Second is it is valid for only small heights. Small height, or we can say when the height is very less than comparison to the radius of Earth. So these two assumptions you need to keep in mind. Then we have studied the motion under gravity. ठीक है, in this motion under gravity there is a important role of sign convention. Sign convention, ठीक है। So the body can go up and the body can go down, in both the cases when gravity is present. अब थोड़ा बेटर आ रही है ना मेरी आवाज? इट्स बेटर नाउ एवरीवन? यस नो ओनली वन इज आंसरिंग, ठीक है कोई बात नहीं। देखो, whenever the body moves upward, we generally consider this direction to be positive, and whenever the body is moving downward, we generally consider this direction to be negative, ठीक है? My voice is breaking, अब नहीं होगी break. Now it's not breaking ना, JNV actually. So we can draw these lines. For upward motion, we will take it positive. For downward motion, we will take it negative. For this motion, we will take it positive, and for left motion, we will take it. Okay. I'll tell you a simple hack how to apply this. This is the convention, and it is not compulsory to follow this convention. Okay. So whenever the body is moving up, take upward direction positive. Positive, and whenever the body is moving whenever the body is moving downward, take upward. ठीक है ना? Take downward direction is positive. So उसके oppositely क्या हो जाएगा? Negative हो जाएगा. So whenever the body is moving up, take the up direction or upward direction is positive. Downward direction will be automatically negative. When the body is moving down, take the downward direction is positive, and upward direction will be negative. Clear? Done. Now I think you are clear with this sign convention. We will discuss two cases here. When body is thrown, and in place of body we will take object. When object is thrown upward with some initial velocity, then the motion under gravity will become, देखो ये मेरा ऑब्जेक्ट है, मैंने इसे ऊपर थ्रो किया है, लेट्स से यू वेलोसिटी, ये ऊपर जाएगा, देन इट गेन द मैक्सिमम हाइट एंड देन अगेन रीच बैक टू द ग्राउंड, ठीक है? सो दिस इज द मोशन, क्लियर? एट दिस मैक्सिमम हाइट द वेलोसिटी विल बिकम जीरो, ठीक है? दैट इज व्हाई इट इज स्टॉपिंग एट देयर. व्हाई दिस वेलोसिटी इज बिकमिंग जीरो? बिकॉज एक्सेलरेशन इज acting in the opposite direction. You can see here acceleration, which is gravity, is acting opposite to the movement of this ball. So that is why it is continuously decreasing the velocity when it is moving up. Clear? No, this is not projectile motion. It's simple. We are throwing it vertically up, na? So projectile motion is not. You can say that but projectile motion is specifically when the ball or the object is thrown at some inclined angle, ठीक है ना, other than 90 degree. This motion is vertical motion. ठीक है, तो equation will become, now I have said that whenever the body is moving up, take upward direction positive. So if I want to calculate the final velocity, which is zero actually, so let's say the height covered by this object is h. So h is covered in which direction? Opposite, sorry, upward or downward? Tell me. The height is covered in which direction? Upward direction or downward direction? First of all upward and then downward, but we will discuss only the upward case. तो upward को क्या लेना है मुझे? Positive. So plus h is equals to, because this acceleration is constant, so we can apply the uniformly accelerated motion equation, which is s is equals to ut plus 1 by 2 at square. Okay, so s here will become what? H ut plus 1 by 2. Now gravitational acceleration will be taken as positive or negative? Who will going to tell me? Just give me a moment. Okay, so sorry for the delay. Varalakshmi is saying that acceleration is considered to be negative. ठीक है, very good, because acceleration is in downward direction. Acceleration का direction क्या है? Downward है, so it is considered to be negative. Minus g t square. So h here is ut minus 1 by 2 gt. दिस इज द मॉडिफाइड इक्वेशन. ठीक है, क्लियर है. नाउ if I just ask you what is the final velocity when it is hitting the ground at this point, what is the final velocity? Can we apply the equation? The ball is like this, move upward, going downward. So I am applying the equation from this point. T is equals to, let's say, whatever the time is, from this time to this time. Okay. So we can calculate the final equation in terms of V and H. So now, अब बताओ, अब body is moving downward or upward? Downward. So what we have to do, whenever the body is moving downward, take downward direction positive. So we will take this downward velocity should be what? Positive. But initial velocity here is zero at the maximum height. So if apply this equation, v square is equals to u square plus 2as. In this case, what it will become? U will become 0. V square is equals to 2. Now, a should be positive or negative? Tell me. In this downward motion, a should be positive or negative? When the object is moving downward, downward को positive consider करना है. Acceleration is downward. No, no, no. Sanket, you are getting it wrong. Acceleration is downward. Gravity is always acting downward. And downward direction में downward वाली terms को ही positive लेना. So this will become what? 2gh only. So the final velocity that you are having is square root of 2gh. ठीक है, क्लियर है. Everyone, is it clear to everyone? ठीक है. Yes and no? ठीक है. Now we will be discussing the equation for free fall. एग्जाम्पल के लिए क्वेश्चन सोल्व कर लेते हैं. लेट्स से देयर इज एन ऑब्जेक्ट which has an initial velocity of 10 meter per second. ठीक है, so calculate what is the final velocity when it hit the ground. And what is the maximum height by this object. Acceleration of gravity is 10 meter per second square, but you have to take according to the sign convention. So find out the final velocity first of all, what it will be. We have the equation. And to apply that equation root 2gh, you need to find out h. Or for h, you need to find out the time. Whenever this, at this point, what is the time when the velocity is becoming zero? So apply very first equation, v is equals to u plus at. देखो, we are talking about that upward motion, so upward direction will be positive. So this u will be positive, but acceleration would be negative. क्योंकि acceleration is in downward direction. V is 0, u is 10 minus 10 into t. So t will become 1 second. So in 1 second, the velocity is becoming 0, which means in 1 second, it is achieving the maximum height. So h max is nothing but ut minus 1 by 2 gt. Ut is 10, time is 1, 1, 10 into 1. This will cancel out, becoming 5 meter. ठीक है, this is h max. Clear? Now, how to find out the final velocity? Is root 2 gh. 2 into 10 into 5. That is 100, which is 10 meter per second. Can you see the same velocity? So, whatever the velocity you have given initially, the same velocity will be in the return side. Okay ना? वापस आते हुए when it hit the ground, the velocity will be same. Or I must tell you a hack. देखो, for this motion ना, this ball is moving up and then moving down. At each and every instant, let's say here the time is t1, here the time is t2, here the time is t3, here the time is t4, t5, t6, and t7. These are at same level. Okay. So we can say that what is the velocity at t1, the same will be the velocity at t7. What is the velocity? So at same point, the velocity will be same. ठीक है, क्लियर है? क्लियर है सभी को? Everyone, yes and no in the chat box, or you can unmute yourself and then see. Okay, Dhruvi Prajapati, it's clear. Clear, clear, clear to everyone. ठीक है, got it. नेक्स्ट पे बात करते हैं. नाउ वी विल बी डिस्कसिंग अबाउट द, सॉरी, अभी यहीं पे ही बात करेंगे ना. इसकी बात करेंगे फ्री फॉल. फ्री फॉल. So free fall is the phenomena when the object is released from some height, from some height, just give me a second, huh? Okay. So when the object released from rest, ठीक है, at some height, तो किसी पर्टिकुलर हाइट पे ले जाकर के when you release the object, ठीक है, आपने ऑब्जेक्ट को सीधा रिलीज कर दिया. रिलीज मीन्स द इनिशियल वेलोसिटी दैट यू हैव गिवन टू द ऑब्जेक्ट इज जीरो. ठीक है. सो एट दैट पॉइंट दिस फिनोमिना इज टर्म्ड एज फ्री फॉल. द बॉडी इज फॉलोइंग freely. Only the gravitational force of attraction is acting on that body in the form of gravitational acceleration. Okay. Am I audible to all? Just give me a moment. I'll just reshare the screen once again. Just give me a moment, guys. Huh? Guys, I'm just rejoining the meeting. Huh? Do not go anywhere. Diksha, I'm making you host. Okay? Okay, guys. Is the screen visible to you all? Now the screen is visible now, everyone. Say yes and no in the chat box. Okay, when the object is from rest from some height with initial velocity 0 or 0 initial velocity. This is the case like this. We're dropping this particular object with 0 velocity. So in this case, the equation will reduces to V is equals to GT. I'm writing it directly. H is equals to 1 by 2 GT square, which is equals to the time of flight. जितना time इसने लिया will become square root of 2h upon. ठीक है? And V in terms of h is also given as V is equals to square root of h. So these three formula you must remember. Clear है? Everybody, is it clear to all? Is it clear to everybody? Yes and no? ठीक है यार, रेस्पॉन्स किया करो आप लोग. ठीक है. So graphs for motion, first of all, we will discuss here. Okay, Bara Lakshmi Likita very. Graphs for uniform motion. So condition for uniform motion is what? Condition for uniform motion. That u is equals to 0. Sorry, acceleration is equals to 0. So if acceleration is 0, velocity will become constant. Okay. So acceleration time graph would be like, because acceleration is 0. So there is no projection on y-axis. Let's say this is acceleration, this is time. So projection on y-axis will not be there. So this is the acceleration time. Okay. Clear? Now, because acceleration ka value is 0. Now, velocity time graph, since velocity is constant, v is equals to some constant number, let's say c. Okay. So it has a projection of c, the value of c, and then it will be constant along time. So at any time you will have the value, you'll have the same value of velocity. Let's say t1, t2, t3, you will have the same value, which is v. Okay. Clear? So this is the graph. Now, the next case is displacement time graph. We can apply the general equation of motion and the uniformly accelerated motion also. So S is equals to what? Ut plus 1 by 2 at square. But acceleration is 0. So S is equals to u into t. Now the variable here is S and t. So can I compare this with line equation y is equals to mx, where m is the slope. So slope is given by u. Okay. So that is why the slope opacity graph, the displacement time graph, gives you instantaneous velocity. And it will be a straight line passing through origin. ठीक है, like this. And the slope is, this is tan theta, and let's say tan theta, which is equals to m equals to velocity. What is the area of this graph? Area means you just multiply these two parameters. So area of ST graph gives you what? S into T, nothing. इस क्वांटिटी का कोई फिजिकल सिग्निफिकेंस, ठीक है. सो ओनली द स्लोप ऑफ दिस ग्राफ गिव्स यू वेलोसिटी फॉर यूनिफॉर्म मोशन. ठीक है. नाउ फॉर यूनिफॉर्मली एक्सेलरेटेड मोशन, so in this case you have a acceleration is equals to constant, some constant quantity. ठीक है. So again acceleration has some value, but according to time it is not changing. Along with time it is not changing. This is the particular same graph is shift. देखो, फर्स्ट ऑफ ऑल जो हमने वेलोसिटी टाइम के लिए बनाया था वो इसमें किसके लिए बनेगा? एक्सेलरेशन टाइम के लिए. अब वहां जो एक्सेलरेशन टाइम के लिए, वेलोसिटी टाइम के लिए बनाया था, कैसा बनाया था? देखो, जो वेलोसिटी टाइम का था वो तो एक्सेलरेशन टाइम पे शिफ्ट हो गया, एक पहले चला गया. इसलिए जो एसटी ग्राफ है वो किस पे शिफ्ट हो जाएगा? वीटी ग्राफ पे. एसटी ग्राफ ऑफ यूनिफॉर्म मोशन इज इक्वल्स टू वीटी ग्राफ ऑफ velocity time graph of uniformly accelerated. So here we can say v is equals to u plus at. Now यहाँ पे दो केस होंगे. If initial velocity is 0, so then you can say v is equals to at only. Again v and t is the variable, you can compare it, y is equals to mx. So the slope will be straight line passing through origin, and this is velocity time graph. So area of this graph, area of VT graph gives you what? It is V into T, which is displacement. ठीक है. And slope is nothing but V by T, which gives you acceleration. ठीक है. Now if u is not 0, then we have v is equals to u plus at. This is similar to y is equals to mx plus c, where c is equals to u intercept on y axis. y axis, और यहाँ पे y axis किसको रिप्रेजेंट कर रही है? v. तो इंटरसेप्ट ऑन v axis, वेलोसिटी एक्सिस हो. ठीक है. So the graph will be like this. You have some value u, यहाँ तक initial velocity, and then same. Slope will be same. If the acceleration is same, slope will be same for both the graph, but the initial beginning of the graph will change. Clear? Now displacement time graph. So displacement for uniformly accelerated motion is given by s is equals to ut plus 1 by 2 at square. ठीक है. Now again here will be two cases. If u is 0, then s is equals to only 1 by 2 at square. This is the equation of y is equals to 4ax square. Okay. So y की value is positive. Whatever the value of x you will put, if s is negative, then also y is positive, because negative का square will give you positive value. So this graph I'm drawing on the one side will be like this. This is a parabola. पैराबोला कर्व. ठीक है. क्लियर है. बट इफ u इज नॉट 0, उस केस में क्या होगा? s इज इक्वल टू ut plus 1 by 2 at square. In this case जो स्लोप है ग्राफ का दैट विल बी चेंज बिकॉज एट t इज इक्वल टू जीरो द डिस्प्लेसमेंट इज जीरो, तो ग्राफ स्टार्ट फ्रॉम हियर बट द स्लोप विल चेंज। ठीक है, क्लियर? Because of this extra term ut. Clear? But you must remember that graph is passing through origin and it must be a parabola. Now, area of dt curve और dt ग्राफ, तो एरिया के लिए क्या कर देंगे, d इंटू टी, ये डिस्प्लेसमेंट टाइम है, तो सेम वैल्यूज रहेंगी, d एंड t इज नथिंग एंड द स्लोप इज d बाई टी, एक्चुअली डेल्टा t बाई डेल्टा t विच इज इंस्टेंटेनियस वेलोसिटी। ठीक है, क्लियर है सभी को? एवरीवन, इज इट क्लियर टू ऑल? ठीक है, तो आज के लिए इतना ही रखते हैं, नेक्स्ट क्लास में क्वेश्चन सॉल्विंग करेंगे इस टॉपिक पे। ठीक है, और जो रिमेनिंग टॉपिक है उन्हें कवर कर, गॉट इट? अब क्वेश्चन सॉल्विंग करेंगे नेक्स्ट 2 डेज, और जो रिमेनिंग टॉपिक है उन्हें कवर। ओके गाइस, if you have any problem in these graphs you can ask, otherwise the lecture is being over. Thank you so much for being attentive and being responsive in the class. Okay, I have launched a poll, please respond in that poll and then you can leave the session.